All right, everyone, we're going to go ahead and get started. This is our first lesson in AP Stats, Chapter 1, the Section 1.1, Analyzing Categorical Data. Hopefully you have the notes printed off in front of you and can follow along. Otherwise, you can pause, rewind, do whatever you need to with this video. So, getting started. What's the difference between categorical and quantitative variables? Well, categorical is pretty self-explanatory. It puts you into groups or categories. Easiest one to think about right there is most of you are seniors. That puts you into a group. You have freshmen, sophomores, juniors, seniors. You have teens, adults. You have, the state that you were born in. Those are the kind of things that put you into a category. Quantitative variables. I think the trick with this one is that you have to remember that does it make sense to find the average? All right, that's how you can usually tell the difference between categorical and quantitative. Now, the reason why we say it doesn't make sense to find the average goes with this next question right here. Do we ever use numbers to describe the values of categorical variables? Well, yes, we do. What are some examples of that? Well, your zip code puts you into a category, right? So if you live in 3706, 064, that puts you into Franklin. So that is a categorical variable that uses numbers to put you into a category. Does it make sense to find the average zip code in this area? No, because that wouldn't make sense. Some people might have the 37067 area code. To find the average zip code would mean absolutely nothing. Okay, so you can use numbers to put you into a category. Another example of that would be like area codes. Right? You can have area codes. Say 615. You got 931. Those are all area codes that they use here around in Middle Tennessee. I even think the area code that they gave us for our classroom telephone numbers is 629. It doesn't make sense to find the average of these numbers, but it does put us into a category. All right. Do we ever divide the distribution of a quantitative variable into categories? This is all the same thing. Yes, yes, yes. Another example that I just like to throw out there is age. And these are just categories that I'm making off the whim. You could have, 0 to, we'll call it 0 to 3 is toddler. You could have 4 to, 12 is a child. You could have 13 through, 19s or teens. And you can have 20 to 64 as adult. You can kind of see where this is going. You could take somebody's age and put them into a category. Now, could you find the average age of people at Page High School? Yes, you could. All right. How do you know whether age is going to be a quantitative variable, making sense to find the average, or it's going to be a categorical variable? Well, it all depends on the question and how it's asked and how it's phrased. What are they looking for? Do they want to put people into categories based on their age, or are they simply just wanting to find the average age of students at Page High School? All right. So just so you know, numbers can be both categorical and quantitative. What is a distribution? Well, a distribution is kind of just a blanket term out there, a blanket term that they use. It tells what values. All right, tells what values the variable takes on and how often. Okay. This is kind of a distribution that you see down here. It tells what values the variable takes on. In other words, these 10 individuals and how often they occur, kind of thing. It's all down here. So here we go. Alternate example, U.S. Census data. Here's information about 10 randomly selected U.S. residents from the 2000 census. You can see that there's 10 individuals right here. Some were born in Kentucky, California, Michigan. Tells the number of family members, etc. So who are the individuals in this data set? This is not a trick question. You might have this easy of a question on a quiz or a test. You literally just copy down everything that they put in the question. So, these are 10 randomly selected U.S. residents from the 2000 census. Pretty self-explanatory. Notice I have not done any algebra yet. So far, I've just only kind of written sentences. All right, that's what AP Stats is. What variables are measured? Identify each as categorical or quantitative. All right, so what variables are measured? You could list these all out individually, or you can kind of answer both of these questions at the same time. So your categorical variables would be your state. You can't really find the average state that somebody was born in or lives in. So state is categorical. Gender is another one. You really can't find the average gender. I don't even know what that would mean. Income, no. You got gender, you got marital status. And I think that's it as far as categorical. All right. Quantitative. It could be family members. Right? You could have family members. You could have age. It makes sense to find the average of these. You could find the average number of family members that, live with these people. You could find the average age. You could find the average income. And also the average travel time. Okay? Describe the individual in the first row. If you can put it all into one sentence, you're good to go. You could say this is a female that is 61 years old. Is 61. This is a female that is 61 who is married with 2 family members, and you can do this in a different order. It really doesn't matter. So this is a female that is 61 who is married with 2 family members. Lives in Kentucky. Has an income of $21,000 and whose travel time to work is 20 minutes. Boom. It's all done. This is a female that is 61 who is married with 2 family members, lives in Kentucky, has an income of $21,000, and whose travel time to work is 20 minutes. Got it. All right. Flipping it over to the next page and notes right here, if I can get it to work. Awesome. All right, so flipping it on the back side. What is the difference between a data table, a frequency table, and a relative frequency table? When is it better to use a relative frequency table? All right, so what you saw up here is kind of like a data table. Data table is kind of like in the raw form. It's kind of like a distribution. All right? Best way I can explain that right there. It's kind of like in the raw form. It just shows you the distribution of all the variables. Okay? A frequency table. Now, this is good. Now, for example, I'll use this gender category that we have up here. Okay? So what does a frequency table look like? Well, it's pretty, just use your common sense. Frequency kind of starts to say, well, how often do these occur? So if a frequency table would be like, well, there are, females. If I counted these up, 1, 2, 3, 4, 5, 6. There are 6 females. It's a frequency. It occurs 6 times there were females. Males, there were 4. All right, that's a frequency table. It starts to, count them up. So it has counts. Okay? A relative frequency table is where it's at. That's why the question says, when is it better to use a relative frequency table? Well, a relative frequency table would look like this. Notice that we went from counts to percent. All right? Relative frequency tables are better because they make comparisons to the whole. All right. So, somebody might say, well, what, we have 250 seniors at Page High School. And you're like, oh man, that's a lot. It would mean more to somebody, or it would just have more significance if, like you said, well, what percentage is 250 out of, the whole population of Page High School? And what happens if it was a small percentage? Well, that tells you right there that there are bigger class sizes than the seniors. You might have a big freshman class or a big sophomore class. Anytime you can take the frequency, table and put it into a relative frequency table, that's probably what you're going to use most of the time to answer the questions that they ask you, just because it makes comparisons to the whole. It makes just better sense in general. Okay? Got it. Really, you're just taking your counts and dividing it by the total. That's how you do a relative frequency. Take your counts, divide it by the total amount, and then that's how you get it. So, what is the most important thing to remember when making pie charts and bar graphs? Why do statisticians prefer bar graphs? Well, you're gonna be making graphs all year long, and I can't tell you enough. Labels. It takes there's always a learning curve with this, because I can tell everybody right now, hey, make sure to label your graphs, your x-axis, your y-axis, whatever you need to do. Make sure to label your graph. And it takes a little time. The guys that, if on the AP exam, if you forget to label your x-axis, they're going to knock you down points. If you forget to label the y-axis, they're going to knock you down points. If you forget to just have context, they're going to knock you down points. So it's the little things that kind of make those nice grades in AP stats. Make sure you always label your graphs, all right? I can tell you right now, you're never going to make a pie chart, okay? You're not going to make pie charts. As long as you can read pie charts, you're good to go. And you guys have seen pie charts for a long time. Pie charts make comparisons to the whole. It's a nice, pie, this pie adds up to 100% kind of thing. So you're not going to draw them, because nobody can really draw a perfect circle and guarantee that that's 40% of the circle, for example. So you're not going to make pie charts. But you will do bar graphs a lot. And bar graphs really are just easier to make. Okay, that's really why we do them. They're easier to make. You're not going to make pie charts. You just have to be able to read them. But you will make bar graphs because they're easier to make. So what do teens post? Here are the percentages of 12 to 17-year-olds who post various types of personal information on their social media profiles, according to the Pew Internet Parent Teen Privacy Survey in 2012. So basically have some selfies right there, school name, city or town, yada, yada, yada. Part A. Make a well-labeled bar graph to display the data. Describe what you see. So if I was going to make a bar graph, looks like I'm going to have percents who post on the side. So percent who post on the side. I'm going to have type of personal information down here. Okay, and it looks like the percentages go up to 90, so let's go up by tens. So 10, 20, 30, 40. Yeah, you guys have probably done this before many times. And let's label the bars. We'll call these selfies. Looks like we have 91%. I'll go up. Got it. You have school name. So that's at 71%. We'll go to where you live, I guess. City or town where you live. That is also 71%. Email address. And you got 53 with that one. And then you also have we'll just call it phone number. And that's at 20%. Alright? So notice, all my bars are the same width, when you try to draw these, that's important. And the bars really aren't touching. You kind of want to keep bar graphs separate from each other. They're not always going to be separate. Some, you'll see here within the next few days that we'll draw bars next to each other. Like if we had multiple samples, and you say like, this is the percentages of teens. This is the percentages of adults that, do selfies. You can have graphs like that, but for the most part, they're separate from each other. They kind of just based upon, the certain categories when they're together. And just, everything's labeled perfectly. That would look good. So we did the first part. Always read the full question, RTFQ. Describe what you see. This is where you would want to write some sentences, and I'm not going to write some sentences out here just because I'm going to run out of room. But this is where you describe what you see. You would say, well, the largest percentage of personal information that's posted out there is selfies at 91%. The smallest percentage of personal information is cell phones that's posted out there. Some similar ones would be, what school they go to or where they live. Those were close to each other. And notice I'm just kind of hitting the high one, the low one, maybe some similarities in there, maybe how they're different. That's all they want you to do. When they say describe what you see, just write a few sentences describing that. Would it be appropriate to make a pie chart for these data? Explain. Well, the easiest thing to look at that is, well, once you start adding up these percentages, they're adding up to being way more than 100%. That's not good. There's a total maybe like 100% of 12 to 17-year-olds, but these are kind of like subcategories within that population. So that's why these add up to more than 100%. So, really, no, percentages add to more than 100%. Okay? Can't do it. That's not good. All right? What are some common ways to make a misleading graph? And you're going to kind of see this here on this next example. Just first of all, always make your y-axis start at 0. Right? Some of you, I always have students ask, you when you make a y-axis on in some other classes, you might have that little break in the graph kind of thing like this, and then like jump up to say 50, and then carry on kind of thing. Notice I have equal spacing. Like I'm insinuating that this is 0 right here, and we're going up by tens every single time. Always make your y-axis start at 0. AP exam, they don't like that kind of stuff. There's no breaks in graphs. All right, so y-axis starts at 0, and you just have, equal spacing. Next thing is, the area principal / pictograph. That's not necessarily an AP term, but that's just kind of what the book uses. I'll use it too. The area principal / pictograph. And that's exactly what's going on down here. What is wrong with the following graph? Well, when you look at this, DirecTV stops the competition. 95 of your favorite HD channels, Dish Network only carries 81 and cable carries 56. Well, this is definitely violating the area principal / pictograph, just because if this box represents 95, why is it that I can take 56, size box and probably fit like 6 of those in here, right? That just doesn't make sense. They're trying to say that 95 is just that much bigger than 56, but it's really not. I could plug in 56 many times over here. That's the way my brain thinks about it. Same thing with 81. How many times could you plug in 81 over here? That would be way more than just 95. So, not a good graph. I would say the area principal / pictograph on this one. Just be aware of those things. I can tell you right now, you're probably going to have some questions on your homework that definitely talk about this y-axis starting at 0 with equal spacing and all that stuff like that. So, there's day 1. You got your homework right here, down here at the bottom. Homework number 1, page corresponds to the right one in the textbook. We'll have an uplink on Schoology for you to turn in your homework. But I wanted to give you this lesson for day 1 on video, just so you can pause, rewind, do whatever you need to do. There's no distractions, and you can learn math at your own pace. I will see you in class with questions on homework. Thank you very much. Y'all have a great day.